Okay, guys. This is Mr. Lewitt. I'm gonna make this video kind of quick. We'll have more time to talk about this next week. During the video lectures. So remember that students enrolled in Math 144, Section 8C2 actually receive live video lectures, while students in the 8C3 section, those are asynchronous students that watch the videos at their own convenience. But I encourage you to watch the videos. When I say at your own convenience, that doesn't give you permission to ignore the videos. If you ignore the videos, if you don't do the work, I guarantee you're just not going to pass the class. And that's not because I'm a mean person. It's because, I'm a teacher and my job is to evaluate student performance. So, I have to give you a grade, and your grade, I can't base your final grade on, oh, I like you, you're a nice person with a pretty smile, so therefore I'm just going to give you an A or a B. No, sorry, you have to actually do the work. And this class really is a lot of work, okay? We have a lot of stuff to do in just 7 weeks. So I'm going to give you just a quick introduction to Mathematica. Let's talk about it. Let's take a quick look at a homework problem that you have. So this is in your chapter 3 homework. Excuse me. You have a lot of homework assignments. Some of them are short, some of them are very long. I think your first homework assignment has 70 problems in it. Your second homework assignment has like 156 problems. The chapter 3 homework has 18 problems. Your last homework assignment has 17 problems. I mean, some of them are short, some of them are long. The nice thing is you have unlimited attempts. So if you get the answer wrong, you can just keep trying, over and over again until you get the right answer. And a lot of these questions are multiple choice, so that boils down to really multiple guess. So it may take a while, but everyone should get at least 90% on the homework, at least. All right. So it says here, question, find the max element algorithm, and it gives you a list of numbers, and it's like, how do you create a function that will find the maximum? How do you create or build a function that will give you the maximum in this list of numbers? So, excuse me, just yawning a little bit. Sorry about that. Let's look at Mathematica. 1 second. Okay, so Mathematica has a lot of different options and stuff like that. We can talk about that more, next week. I don't want to get into all of that right now. But just very quickly, you can, make your font bigger, smaller, bold font, regular font. It's very simple. Just go into Edit Style Sheet, select Input, Output, whatever you want, and you can change, you can change stuff. All right. Now, by default, Mathematica doesn't put in those pretty commas for really big numbers. To do that, you would have to go into Option Inspector and type on click on Global Preferences, Number Separator, and then make sure that's a comma right over here. That should be a comma. It doesn't have to be a comma. You can make it whatever you want, but I recommend that you use a comma. But again, it's your choice, okay? It's your choice. Okay, so enough with that. How do we find, well, first of all, what's our list? Practice list is equal to 1812, 1812, 9112, 9112, 9112, 14, 5, 10, and 4. 14, 5, 10, and 4. Shift Enter. Okay, so press Shift and then enter. Hold down Shift and press enter to execute a line of code. There we go, Shift enter. Okay. So I'm going to build a recursive function. I love recursion, and recursion, excuse me. I didn't get enough sleep last night. I'm tired. Recursion is used a lot in this course. A lot of the algorithms in discrete math rely heavily on recursion. So recursion is when a function calls itself. All right, so let's see what we have here. Find maximum. And I'm going to use some pattern matching. If we have a list with just one element, that the underscore means one element or one number. Let me type that again because you guys have to understand that. I don't care what letter you use, ABC, XYZ, whatever, I don't care, all right? If you have a list with one element, the maximum is simply going to be that element. Shift, enter, okay? Now, let's see, what if, what if you have a list with two or more elements? Okay, so what does this mean over here? So this is a list, okay? There's a number here represented by X, and the underscore means just one number or one element. And Y is another number. The underscore means one number or one element. And this is the rest of the list. Now, what do these three underscores mean? The three underscores actually means 0 or more elements, 0 or more numbers, 0 or more values, okay? And let's see, I'm going to use an if expression. If is easy. Let's see, if 5 is greater than 3, 5 is greater than, give me back the string, 5 is greater than 3, or 5 is not greater than 3. All right, well, obviously this is true. This is a true statement. So the answer is 5 is greater than 3 rather than 5 is not greater than 3, okay? So let's see. If X is greater than Y, if X is greater than Y, then we're going to do find maximum, okay? X join Y's, okay? And if 5 is not greater than Y, then we're going to do find maximum Y join Y's and close the if expression. So let's see if that's true. We really don't need this. Let me get rid of it. Find maximum of my practice list. And indeed, it is 14. It is 14. Okay, because 14 is bigger than 1, 8, 12, 9, 11, 2, 5, and 10, and 4. Okay? Now, how can I use find maximum to find the minimum? Well, now think about it. So what if I turned all of these numbers into their negatives? How would I do that? Well, -1 times any number. This is called an anonymous function. -1 times any number, and you need the ampersand, and I'm going to map it onto my practice list. So that's going to give me -1, -8, -12, -9, -11, -2, -14, -5, -10, -4. Okay, so then what is the maximum number of this list? Let's see, the maximum, it looks to me like the maximum is -1. Okay, so that means, let's see, that's the very first element of my list, which is -1, and I'm going to multiply that by -1. So that's how I find the minimum value of my list. Let's create that function. Find minimum of some list. I'm going to create a module. Okay. And in my module, I'm going to say neglist is equal to -1 times some number, map it onto the list. Okay. Create another module for creating these so-called local variables. And then I'm going to find maximum is equal to find maximum of my neglist. And then finally, negative of the maximum. And that is the minimum. Close the inner module, close the outer module. Press Shift Enter. Find minimum. Practice list, and it should give me 1. Because 1 is smaller than 8. 1 is smaller than 12. 1 is smaller than 9, 1 is smaller than 11. 1 is smaller than 2, and 1 is smaller than 14, 1 is smaller than 5, 1 is smaller than 10, and 1 is smaller than 4. Okay, and yes, you can do all of this in Racket. We will talk about Racket next week. Racket is similar in some ways to Mathematica, but it's also a little different. It's a little bit different. Okay. Let's see. Could you use for loops to do this? Yes, I think some of you are more comfortable with for loops. It would be okay to do that, but I do strongly encourage you to get used to recursion, because recursion shows up a lot in discrete math. It shows up a lot in discrete structures, which is basically the computer science version of discrete math. And recursion is used all the time in data structures, algorithms, advanced algorithms, cryptography, artificial intelligence, robotics, you name it. Recursion's a big deal. So you have to get over your fear of recursion. Recursion is not your enemy. It's something you're going to have to get used to. But you could use a for loop. So how would I use a for loop? Okay, let's say, let's try this. Find maximum, find maximum alt, which means alternative. This is another way of doing it. List. Let me see now. What would be a good way to start this? Module creates a local variable. Okay. Max value, or I could just say maximum, is equal to list 1, which is the first element of the list. It's not going to be list 0. In Racket, it would be list 0. In Mathematica, it's list 1. All right. And then for k is equal, no, this is not Java or C++. I don't have to do this. Okay, I don't have to do this like in Java or C++. So it's going to be k is equal to 1. K is less than or equal to the length of my list, k plus plus, k plus plus. I'm making a video, so okay. All right, just, okay. K is equal to 1. K is less than or equal to the length of the list. K plus plus means I'm incrementing the value of K by one step. And then follows the body of my for loop. Hold on 1 second. I can't talk now. I can't talk now. I'm making a video. I'm recording a video.
Okay, check my car. I think it's an A350. I think I'll say.
You just got recorded on the video.
Okay.
There.
Okay.
Okay. So let's get back to this. Okay, so then we're gonna do if list K is greater than, is greater than the maximum, then the new maximum is going to be equal to list K. So in Mathematica, it's okay. You got to be careful because, hold on 1 second. So in Mathematica, you have to be careful because your if statement can have only a then clause, all right? But in Racket, your if statement must have a then and also an else. All right, so in Mathematica, your if statement, can have just one clause. But in Racket and some other programming languages, you can't just have a then clause by itself. You must also have an else clause. You need two clauses. But in Mathematica, one clause is sufficient. So if list K is greater than the maximum, you're going to update the maximum value by saying it is equal to list K. And we're going to close this, semicolon, and then return the maximum of that list. And then shift enter. Then find maximum, alt, practice list, and that should give me 14. Shift enter, 14. So here we're using a for loop. We're using a for loop instead of recursion. But there are instances where you can't use recursion. You can't use recursion. I'm sorry. I got that backwards. There are instances. There are many problems in a class like this where for loops are either not practical or they are impossible. And in Chachki, stop. There are many problems in a class like this. There are many problems in mathematics and in computer science where a for loop is not practical or it could even be impossible. And you really need to rely on recursion in order to figure out a solution to the problem. Okay? Okay, so we're going to be brief. Let's make this video simple. And let's see, how long has this been? Okay, just about 20 minutes. Okay, I think that's going to be enough. And we'll go over more of this next week during the class lectures. Okay, thank you very much and have a great day.